mobile was invented, they just have one thing in mind: cell numbers and contacting a person with corresponding cell number. Which tells us that contacts is probably the most important thing that you have to know given a mobile device. So the contacts API, the particular Android phones that all of us use, they use something called a contacts API, which is very similar to the normal content providers which we have worked with already. The interface. So this API, as we know, the Android platform is changing really fast. So obviously this also changed. It changed with Eclair, that is Android 2.0. The class that was used prior to Eclair, that was Android.provider.contact. Now what happened? What was the problem? Why did they have to change something like that? Before we know what the problem was, we need to know what was in the first class or the contacts class. So they had something called people. They had a table called people. That's pretty obvious because you need to have people. You need to have their phone numbers. You need to have extensions because they may have a home number, they may have a cell number, they may have an office number, they may have things like that. And then groups. They might be a family group, they might be a friend group, they might be different groups, different work groups. And then the group membership, you have photos of people. This is all metadata. The primary thing is the people and their phone numbers. The rest, everything else is metadata. The photo of the person, the group he belongs to, the group membership, the organization that he belongs to, the contact methods, etc. Everything else. And then you also had settings. If it was so clear cut, if it was so well normalized, then what was the problem? The problem was there was no thing called aggregation. And it also had another problem. The contacts were limited to just one source in the compatibility mode. In other words, you could retrieve data only from the first Google account that was first put in that device. That is, if you have more than 2 Google accounts, which most of us do, then it would retrieve data only from the first Google account that you actually entered in the device, and no aggregation. I, for example, have 3 accounts on my mobile phone right now. I have my Facebook account, I have my Google account, I have my Yahoo, whatnot. If I had another account, I would probably have that too also on my device. That old API did not support aggregation of all these accounts. It did not support it did not support the aggregation of the same person who had 2 or more accounts on the same phone. So it was highly beneficial that they had to upgrade the API, they had to introduce all this stuff. The new API, this is superseding the contacts API. This is called contacts contract. Funny name, but I think they gave it because they thought it was a contract between the content provider or the contact provider and the person who's actually querying it. So this provides a level of abstraction. How does it provide a level of abstraction? This follows a 3-tier architecture, which is very intelligent, and it now provides a layer of abstraction. The sources from the different sources of the same person can now be merged very, very efficiently. How? First, let me show you that. This is how they do it. They follow a 3-tier architecture in the sense they store data, they associate data with a single person, and then they aggregate the data of different accounts to the single person. So this is where you actually store the data, this is how you associate the data of that particular account, and this is how you aggregate all the particular accounts of a single person. How do they do it? They have 3 main tables that they do it using. So the first table is the contacts contract.data table. What is in that table? All the personal data that you need for a given contact or for a given person is here. For example, the name of the person, the phone number, the email address, so many different things. All this is stored in a generic column. The generic column is called the data column. And the obvious doubt is, if you have a generic column but you have so many different types of data, how do we recognize it? We recognize it using the MIME type of that column. For example, you have various different MIME types. If you have a phone MIME type, then probably you'd store a number in that particular column. If you have the email MIME type, then you probably store the address in that particular generic column. So depending on the MIME type, you store in the generic data the most relevant information. And now in this particular data table, all you have is the personal data. When you're inserting data into this particular table, you have to make sure that you have something to individually or uniquely recognize each record. That is done by using the ID field. Each contact that you insert in this particular table has a unique ID field. which you can retrieve it. Next, while inserting, you can either insert it individually, one record per record, or you can actually do it using the batch processing. Most of the people prefer the batch process insertion when compared to the individual record insertion. This is because, firstly, all these batch process insertions are atomic. All the transactions are atomic in the sense you complete the transaction and then you go do something else. Also, you'd save a lot of time because you would not lose a lot of time context switching between the processes. I mean your process in which you are inserting the contact and the process which actually is using that, in which the contact provider runs. So you won't lose a lot of time in context switching between these two processes. But as Dr. Feifei says, there's no free lunch, so there must be a flip side to this. What is the flip side to this? The flip side to this is, whenever it's a very long or a huge transaction, then it blocks the database and you have a lot of ANRs. So how do you deal with this? They actually came up with an interesting solution to this too. They came up with a concept called yield points. So what are yield points? A yield point is actually a break in this particular transaction. That is, you can tell the content provider or the contact provider that I finished this part of the transaction. If there is anything, any other application or any other request, then you can go to that particular request, finish it, and then come back to me. So obviously the yield points will have to be placed in the transaction to be mutually exclusive of individual atomic transactions in themselves. That's how the data table works. And then to the next part in the 3-tier architecture, the raw contact. What happens here is all the data which you have in a single contact is now aggregated here. When you actually insert a contact in your contact manager, it first checks to see if this person is already in the particular phone. If he is, then he just aggregates the data to this particular contact. If there isn't, then he creates a new contact and then he does all the process. So here in the first level, we have something called ID, which uniquely identifies each and every record. In the second stage, we have something called raw contact ID. And in the third stage, we have something called contact ID. Each table has the ID which is used to uniquely identify the record. But then this raw contact ID here is like the foreign key to this ID, and the contact ID here is like the foreign key to the raw contact ID. Basically, you are trying to link these tables so that you can efficiently query the tables at a later time. That is the whole point of the aggregation. You just want data to stay close to each other. This is how it does. Like for example, you have email, you have the work email, the work phone. That is one particular system. And you have the personal email, the personal phone. That then becomes a raw contact ID. That this contains all the information about the personal account, that contains all information about the work account. But then everything is to do with Bob. So all these are further aggregated to the contact Bob. So how does this contact aggregation work? It works in 3 different modes. These modes you can specify while you are actually entering the record in the particular phone. Aggregation mode default, this is where auto aggregation is allowed. In a minute I'll tell you what auto aggregation is all about. And then aggregation mode disabled. In this you're not allowing aggregation, you yourself aggregate. Aggregation mode suspended. You've allowed aggregation so far, but you're not allowing aggregation henceforth. So all the existing aggregates are maintained, but for the new ones are not. The aggregation is suspended from now on. So automatic aggregation. When are 2 contacts automatically aggregated? They are automatically aggregated if at least one of these conditions is met. If the names are same, obviously, and if the order is different. For example, if it has Mridula, Singampalli, Mridula, whatever, it uses brain and it just aggregates those records. And then if the names are the same, but you have a nickname specified. For example, you have Bob somewhere, but you actually entered Robert now. Then if you actually told the machine that this Robert or Bob is actually the nickname, the Bob is actually the nickname of Robert, then it actually understands that and aggregates that. And they don't have the common first name, they don't have the common last name, but if the email address, the phone number or anything like that is similar, then it identifies that it must have been a typo. Then it aggregates that stuff. We have a lot of other tables apart from these 3 main tables, that is the data table, the raw contacts table and the contacts table. These 3 are mainly for the 3-tier architecture, but apart from this we have a lot of other tables like the groups table. This has information about the sync accounts, like for example my Google account or for example if I'm using my Motorola phone, so I have my Motorola account and stuff like that. In this, the current API does not support information across multiple accounts. I mean, you cannot retrieve it all of a sudden. I think that's something they're working on right now. But you have information like the title of that particular account. You have the information like if is the group visible, are the members in the group visible. For example, I have a group called family in which I have 10 members. Now it's up to my discretion whether I have to show if these family members are visible via an interface to all the other members. Next, I have a table called status update. This most of us use because it tells us about the social network updates and the IM availability. So this is, for example, you're in class and you want to post a message saying having lunch via Google Doc. Then it captures both these. It captures the status and it captures the account via which you actually posted this message. So it has various columns which help it do that. For example, it has the status, which is actually the status that I've posted. It has the IM account through which I've posted. It has the presence, that is, am I online, available, away, don't want to be disturbed, everything like that. And it has other information like the status timestamp. The status timestamp when I've actually posted the status, and it's precise up to, I guess, milliseconds. Yeah, and then you have aggregation exceptions. Just now we've discussed automatic aggregate exceptions. But what if I don't want to use the automatic aggregation? Then I can actually tell the phone when to aggregate stuff. I can actually give it the rules and the conditions. I can specify everything by myself. I do this using the aggregation exceptions. All this is to do with the manual aggregations and the manual disaggregations. Next, we have the settings table. This is used for the setting the visibility and the synchronization of the accounts. For example, you can change a lot of stuff like when you actually last updated your contacts, what was the last time you updated your contacts, and the number of contacts you have right now and all that stuff. And then the synchronization state, there are a lot of synchronization adapters. Contacts is all about synchronization. That is why we actually updated to this API. So you have to all sync these information about the accounts. For example, you delete a contact, contact in the third tier. Then you have to make sure you deleted all the raw contacts too. Phone lookup. So I'll hand over to Jeff to take you through phone lookup and the key code.
Okay, well, the phone lookup table is basically just an optimized query to look up a contact's name from the phone number, because when your phone receives a phone call, obviously it gets the phone number and not the person's name, so it wants to get the person's name from the phone number so it can show it on the screen. And that's all that is. It's just optimized for the reverse lookup, basically. Now, the lookup key, basically, when you have multiple accounts on your phone, and there's a lot of account syncing and a lot of contact aggregation going on, I mean, obviously, primary keys for the contact table are not very reliable because they can change all the time if you're syncing with a whole bunch of accounts. So basically, Google provides a relatively static field called a lookup key. I'm not sure how this is actually generated, but it's supposed to be much less volatile than the actual primary key of the contacts table. Okay, so API compatibility. As it was mentioned, the API changed in Eclair, which is 2.0. And it's definitely beneficial to upgrade the API version, because if you use the old API in compatibility mode, then you don't get access to all of the contact sources. You can only have the contacts from the first Google account on the phone. So it's definitely beneficial to use a new API, but it's also beneficial to support the old API, so you don't, people who use older versions of Android can also use your app. So there's a few different options. Obviously, you can use the old API and run it in compatibility mode, but there are disadvantages. You could drop compatibility with the old API, but then you lose all those people who use older phones. You can maintain two different versions, which also has issues because you would actually have to publish them in the marketplace twice. And then you can support both APIs in the same app, which is actually not that hard. This is sort of an example, but I'll show you that in Eclipse. Okay, so most people familiar with object-oriented programming should be aware of something called polymorphism, which basically means you have a base class, and then you can have child classes that actually inherit from it. So in this case, to support both versions of the API, we actually have an abstract class called ContactAccessor. And you have a static class member function called getInstance. And basically what getInstance does is it returns a different child class depending on what version of the API that is actually needed for the current phone. Now you can see there's some weird syntax here because you can't actually call the classes by name because, obviously in older phones, the contacts contract class does not exist. So if you actually hard code the allocation of these classes, then you're going to have compile time errors. So your application won't even compile on the old phones. So it kind of defeats the purpose. So here we actually check the SDK version, and if it's older than Eclair, then it actually allocates a copy of this class, which I'll show you. Otherwise, it allocates this class. Okay, so this class is basically just for versions of Android older than Eclair. And in this case, the only thing really different about it is instead of importing Android.provider.contacts, it imports Android.provider.contacts. So basically when you want to load a contact, it gets the information from the older tables. Now in this case, this is for newer versions, and it actually gets it from the newer ones. Now this application is actually very simple and doesn't require a whole lot of functionality. All it does is allocates the accessor based on the version of the API, and then just calls the intent to pick a contact for that particular version of the API. So this application doesn't really do a whole lot with the contacts directly, it just hands it off to the system components. Contact manager. Okay, so Contacts Manager. Okay, so this just populates a spinner with all of the contacts, basically. Okay, and this portion of the code actually demonstrates the batch processing of adding contacts to the content provider. And you can see it develops, it uses an array list of content provider operations, and that's just a class that describes an operation. And the useful thing about batch processing is that you can actually reference prior inserts within the same transaction. Like in this case, you want to access the ID of a field that was previously entered. In that case, you can just use with value back reference. Okay, so this is another example of using polymorphism to support both APIs. And this is just abstract class. And you can see all of the old API members are actually crossed out because they're all deprecated. In order to suppress those, you have to add the directive suppress deprecation. So all this does is it basically just populates a spinner with all the contacts in the phone. This is the newer version. So you can see accessing the contacts API is actually exactly like accessing other content providers. There's not really anything special about it. So this is the business card application, and this is the application that supports both versions of the API, and all it does is gets the correct version and fires up an intent to the actual system utility to pick a contact, and then when you pick it, it shows you their name and phone number, so nothing special. And this is another version. It also supports both versions of the API. And you can see I have two contacts here that have the same name, different number. And it's not actually shown here as being aggregated because this program actually just pulls all the raw contacts from the phone rather than the aggregated contacts. Okay, so there's another feature of the Contacts API that is somewhat useful, but in general, you can have accounts on your phone that are syncing in some cases, but you know, if you're one of the people who has like 10,000 friends on Facebook and you don't want all of their names and phone numbers in your phone, then you can tell your phone not to sync contacts from Facebook, or to only sync contacts from Facebook who also appear in other groups in other accounts. and then they're just aggregated with those. But in a lot of cases, they are actually still in the content provider. They're just marked as invisible. See, if you actually want to query every contact, they're all there. And in a lot of cases, that includes people you email a lot in Gmail. Questions?
So I have a question about testing. You wrote an app that can work towards a 1.5 API and a 2.0 API. How do you go about testing?
I left that to Google. It was a Google sample.
This is actually an interesting question for Google. When I was there last summer, they were saying they were having a big problem with this because now they don't only have X versions of the API, but they've got hundreds of distinct devices now, and they kept a closet with at least one of every device that was there, but they could never seem to find the one they needed to test on.
I have a question about the site. So when you're adding can you add a contact to their little interface through that little program?
Yeah.
Okay, so when you do add a contact, do you add it at like the lowest level and build that hierarchy up?
Well, actually, the way it works is you add a raw contact, and then it'll either be automatically aggregated with other contacts, or you can set one of the aggregation modes and aggregate it yourself. But yeah, in general, you only add it at the contact at the second level, and add the metadata at the third level, and then first level is basically just aggregation information that's almost entirely volatile.
You never add explicitly at the topmost level. It's all aggregation at the topmost level. You only add it only at the basic level, and then you aggregate it at the second level. You can insert only in these two levels. That is done explicitly.
So is aggregation a tree or is it a graph? So what if I had a situation where I have a business email address and there's two people that basically run the business, two owners. They both kind of want to claim those emails.
They'd have different names.
info@business.com. Right? If you want to control it, I guess you don't want to control it on the phone, you want to control it by having info forward to the two owners.
If I believe if that email address is under different names, then no aggregation will occur. But if that email address is standalone, yeah, so if that email address is standalone and it's also under both of their names, then technically that raw contact should be aggregated with both of them in one person, but since they have both names, they both have different names, then I'm not sure how it would work.
It will be aggregated because here, I don't know, in some weird way, Google gives importance to email addresses than to person names. They consider names as metadata. So the thing that you're actually recording is the number and the email address. So everything else is just metadata.
Other questions? All right, well, there isn't time to do the evaluations